I'm afraid of Okay. Everybody, thank you. Thank you for coming down. All right, we got a good crowd, a lot of like new faces. So this is Software Internals 2, second meetup. I see a couple of new people. Just so I get a little bit icebreaker, I did this last time. Raise your hand if you weren't here last time. Who's new? Okay, that's like over half. Who has been here? Who was here last time? Okay, so we've got a lot of new faces. I'll ask some hand raising questions just so we can get to know each other and see who's around. So one that I'd like to start off with is who's moved to Miami in the past like 3 months, 4 months? One, we got two. Okay, who's been in Miami for longer than 6 months? Like 6 months to a year. Okay, majority. How about 1 to 2 years? Yeah, okay. More than a year. More than 5 years. The lifelong people who've been in Miami. You were born and raised, I guess. Yeah. Okay. Who likes dark mode? Nobody likes dark mode. How about light mode? Okay. And just how about this? Let's do this. Who is more on, say, the cybersecurity regime or cybersecurity space? We got one. We got two. Okay. Who buckets themselves, say, in the AI world? Okay, we got a few. How about into like the entrepreneurial category, starting a business? Okay, we got the entrepreneur squad here to the left. And how about other in the other round? If I didn't miss it, okay. How about this? Let's do like the cloud native kind of world. We got one, two. Okay. And let me think. Any other good icebreakers?
The tab for StreamYard.
Tonight we have 2 talks by Vlad and Jordan. I'll let them introduce themselves and what they're going to be talking about. Okay, we're live. So Software Internals, what is it? Why are we here? This is meant. I wanted to start Software Internals to emulate meetups that I saw in New York. Since coming down here, I couldn't find a meetup similar to the existing meetup ecosystem down here in Miami. Specifically, I wanted to create a technical meetup where all the engineers and technical people in Miami can meet up and simply learn from one another and just have technical talks. People talking about what are some of the gnarliest problems they're working on, what are some of those like foundational knowledge that they know they want to share with people, kind of in that vibe. Yeah, we have two speakers tonight. I want to thank you both for filling the slots. I'll let them.
Oh, yeah. So, hi everyone, I'm Vlad. I will be presenting more technical, mix of testing topic. Just everyone probably who program face this problematic part. And the only way, as we know, the only thing that works in testing is like not testing. So, yeah, we will discuss this. And most of my speech will focus on so-called Go language, Golang, is like my loudest one. But it's actually kind of similar in other languages, so yeah, feel free if you see something in common, because practices are kind of similar. So yeah, let's start from probably everyone, or most of you saw somewhere in time this pyramid, so-called like testing pyramid, that describe different level of tests that you usually have in your system. So from the smallest ones that's called unit test, when you test whatever small piece of code, integration test when you have some kind of modules, a connection to databases, whatever external stuff you have, and E2E test or end-to-end test when you try to test your system from like everything in your system, from user clicked something to whatever result you have, and acceptance, it's okay. Everything works smooth as you want, like your product manager clicked, CEO is happy, and everyone does something as expected. But there are also many other like type of tests that are not kind of fully part of this pyramid. So a lot of stuff. So there is kind of a load testing when you try to identify that your system works under a certain load, when you need good performance contract testing, when you have, like, let's say, if you are not small team or startup, but like enterprise, whatever, Netflix, and you have a lot of teams that has like different parts of systems, and you have like specific contracts between different services, and you need to keep them, keep results same and non-breakable. So we had people from security, so it's also like separate type of testing when you need to be sure that your system is secure at particular levels that you require, because I'm from blockchain industry and we spend like months for this part. Engineers discover all dependency. Okay, some Cosmos SDK changed some dependency, and you need to sit for months checking, okay, what changed? Should we use that or not? Whatever. And this fun testing that Netflix some way in time introduced. Does anyone know this? Probably. Yeah, so it's called chaos testing. Chaos, probably chaos, yeah. When you try, so it's also like Chaos Monkey was the first framework that was introduced by Netflix, and it's when you try to crash some part of your system and test reliability of your system and like disaster recovery, whatever. So it's basically if you have 10 servers, you try to crash whatever 3 random services and validate everything keep works. So, and right now, yeah, I want to focus on just small part of all these ecosystems, even more part of tests, but I like this GIF, so I wanted to add it here. So yeah, we will talk mostly about like unit and a little bit probably integration tests, and particularly as I love Go, I will provide Go examples. So, and yeah, I wanted to like share some kind of ideas or like experience about multiple approaches. Most of them are pretty common through different languages. But yeah, as I like go from one job to another job, I usually at each new job, I see some new approach to testing or new way to test things. So it's pretty explorative, and yeah, you can find something new for yourself. So we will talk about these 6 parts that I extracted, that it's not just, okay, you write unit tests for a function, but something probably more interesting. So first one is like a common Go approach, probably who writes Go sorry about that, but I didn't see it's really in other languages, but it's called like table testing, when you basically write your test case in a part of one case, and you will have some kind of similar table. And you can just whatever test your in structural way, your different edge cases, whatever, expected errors, and it just looks great to me. Yeah, so it's pretty straightforward. So you run like over your over cases. So the only requirement here is like all your tests should go through same logic. So in this case, you can build such table tests approach, and yeah, in Go it's like pretty common way to run your unit tests, and like not only unit tests. So with this approach, it's kind of difficult to test like a big flow like through like user tests, like create user in database, after that do something with user, update, delete it. In this case, you will do some kind of just common regular test. So that's the first one I wanted to mention. Second one is more like mock-in stubbing and dependency injection. Yeah, it's pretty probably same in almost every language. So dependency injection, does everyone know about? Okay, yeah, most of people know. So yeah, when you not pass a particular object, but you receive like interface or something that can execute particular like part of logic. It's not particular object you receive. And in this case, during testing, you can substitute it with whatever like function, file, or mock, or stub, or whatever you need. So let's say if you have an external dependency to some server, I don't know, OpenAI, you don't want to use OpenAI during your testing, you probably want to use something simpler. If it's like more difficult test, it could be like, I don't know, some Llama local, running local Llama, or you can wrap it as just mock, and it will provide you responses. So in this case, you can do much simpler tests and more stable. So you don't rely on whatever external dependency, you don't rely on database, you can mock your storages. It's kind of common way to substitute. Let's say if you have dependency on Redis as your caching layer, you can like skip it and put like whatever you need, like, I don't know, in memory cache. So yeah, in this case, you can test more difficult dependency and things just by mocking, stubbing. With mocking, there are a lot of problems. So usually, eventually mocks are like awful thing, but everyone use it because with mocking, you usually in the long run can face something when mocks work, but real system doesn't, and you cannot catch it. For this, you need like another layer with E2E test, because we use mocking because it's simpler and like it saves time. Another kind of close topic to this is like golden files, fixtures, and I added here VCR. VCR, it's more like it's a library. It's common in Ruby, and from Ruby it was migrated to Go also. So I like this style when you need something related to HTTP servers or external dependencies. It has API, and so what it does, it's basically first time you run test, it will that depends on whatever external server. It will make the request, common HTTP request, to the server. And when it gets the response, it will store everything it got from the response in a file, and it will save it. Every other time you will call the same endpoint, it will not go, it won't do any external stuff, but it will go to your file and just return it. So it's same kind of creation of these mocks, but more advanced. There are similar approaches for on network level, where you can on a local host change like DNS, whatever, and intercept your HTTP requests and do whatever you need. But like the most simplest one I've worked with is VCR. So when fixtures is golden files, it's kind of similar but a little bit opposite stuff. So golden files is when you have a huge input and you want to test it. Like usually you don't store it in the code somewhere here, but you can just offload it to file and extract from there. And fixture is the same, but for output. When you have some output you want to test again, yeah, you store it somewhere. It's like in Node.js you have kind of snapshots or something like that. Oh yeah, the third one, like Go is a native concurrency out of box. That's why I love this language also. Yeah, one of the important part you need to test in such kind of parallel language and concurrent one, it's like concurrency. In, for example, Node.js, it's not, there are no probably most of these problems you can face, but in Go, you need to care about concurrency. So there are like, this is like probably one of the most useful command that you can run your test with. So it's like -race. And if you here like a simple example where you have like your like common in Go, where you have your counter and your counter can be concurrently accessed, and you just do incrementation, like simple add one. And if you run it without like such mutex, in Go it's pretty common, like and just try to increment your count, you will have this race condition, and like if you run it 100 times in parallel, this test will fail, just because you try to run 100 operation in parallel concurrently. It will be like 95, 94, 98, but not 100, just because you face this kind of race condition. And you also need to test particular Go programs against this like race condition, and it won't help you catch probably deadlocks or something like that. So I remember only once in practice I catch some deadlock with this, but usually it can provide you an idea if it's good enough, if you don't forget anything or something like that. So yeah, it's kind of such stuff that you usually test in Go. New company, new discovery. So at new one, I discovered this type of test, short tests. So it's when you, like in a blockchain, you have like some kind of a lot of unit tests, integration tests, but also you want to test against mainnet. So in like blockchain world, there is like Bitcoin blockchain, you want to test something against it. And in this case, usually those tests are like so heavy, so long, so you don't want to run in CI it's over and over again. And you, let's say, want to do it before PR is merged. And because of that, like there is such stuff that's called like short testing. So you can run with minus short, and it will run all tests except like those where you skip. So you can check against short if this test considered short, not short, it can be skipped. So yeah, so it's mostly useful if you have heavy tasks. So approach I used before called like build tags. So I usually like build a lot of like local tests that I can use my local environment with. It's kind of similar to integration. But yeah, I discovered this one. Probably it can be helpful for someone. Pretty useful. And the last one, I've never used it, but just know, probably would be interesting for someone. It's fuzzy testing. I don't remember, it was introduced in Go 1.18, I believe. Yeah, so it's basically kind of similar to just common unit test, but it does interesting thing. So here you can see that it identifies like seed. So here I wrote a simple test, one like for normalization of URL. And what fuzzy test does, it uses these seed values, and it tries to put input values like randomized with different like potential edge cases. So in this, if in string values, it can be empty string, Unicode, some kind of rune swaps, whatever. So it can try to change and make your input as awful as possible. And so you can try to catch edge cases that you didn't think about. With practice, I'm not sure how practical it is, but like for some reason it was introduced. So I believe it really is. So yeah, just like mutating of your input as diverse as possible. So you can try to test it against like different edge cases. Like, yep. So, and yeah, if it compiles, ship it. It's usual practice. And yeah, please don't. Yeah, no one loves it. So especially your product. Yeah, so that was like short. Yep. Yeah, short. Questions? Yeah.
Just a comment. I really like the golden fixtures thing. I was always thinking about how can we make the OpenAI stuff, come back, but also not have to change like the JSON every single time if we have like a mock data, right? So at least with golden fixtures, maybe if we make some small changes, it will actually make the calls, but at least it'll save it. So if we make other places changes, then it can just use the golden fixtures. Is that something that you think is a good idea?
for OpenAI, so when I built like a system that like requires testing, so there is a little bit different way how you can test. It depends on what exactly do you want to test, but if you want to test like quality of the model, and if you have a lot of like input data, you can like usually you can validate like quality using another model of your current model. So it means like let's say you have version 1 and version 2, and you have third like model that evaluator,
Right.
and you pass same input, you get output, you have like expected best
Right.
like human evaluated output, and you can just compare using like this third model your output. So it's kind of common testing, like it's more like benchmarking, not like testing, but you can also write kind of tests if it requires, let's say if it requires to be in this format. It depends on like
Actually, interesting point, on the actual quality of the outputs. I wasn't really thinking about the quality just yet, because I thought it's very subjective to kind of figure out the quality, unless you're saying there's objective measures that.
yeah, if let's say if you have like, let's say you want to do a lead score, yeah, and all the model should do, it's like, okay, provide me point like number from something to something, like 0 to 10, how good this lead is, and you can evaluate like particular like numbers. Or if you have like JSON output for like for your prompt, at least you can validate, okay, it's always like everything in range, everything like with a good structure. And yeah, you can compare like if let's say you expect some words inside your like, but yeah, if you have a way how human can evaluate it, you can probably create this evaluation model. And yeah.
Interesting.
Oh yeah.
Have you tried using natural libraries at all in your testing? Things like Eureka?
Not really. So I like for Go, I mostly like use this out-of-box approach. So like mostly that. So the only like big framework for testing was like for TDD when we were testing. So step functions in AWS. So we needed to create a full step function pipeline. So it's like basically workflow in AWS, and we needed to create like to set up S3 bucket, to set up storage, to set up database, to set up whatever. We spawn that and start workflow, and using Go, this TDD framework, it's like basically it's similar to test suites in Go that you have out of. No, it was 4 years ago. I forgot, and yeah, I just used it once, but I didn't feel it was useful, so I used it just because it was already there. So if I wrote that, I would wrote it just as common like Go, because in Go communities, usually what you see, it's usually like pure Go, whatever, like simple libraries. But yeah, so yep.
What is your take on TDD and BDD?
I've never tried BDD. I try when I was hired to this company. It was like TDD approach, and it was expected. But in practice, I've never used TDD as like as it is. So like write tests, fail it, do like whatever minimal changes. So I use half TDD. So, but before that, when you try to understand the problem, you usually already expect some kind of cases you need to process. So you write some interfaces, you can try to write tests, but usually you, after that, you code everything, and after that, you start thinking about edge cases. So it's not like TDD as is. But yeah, some people use it, like, okay. So it's more like cultural stuff.
Yeah.
Oh yeah. Ted?
You say you work with blockchain.
Oh yeah.
So what is it, are you able to say what blockchain you work with?
Like name?
Yeah.
Kava.
Kava?
Yeah.
Oh.
No questions. Okay.
Thank you, Ryan. Thank you.
I'm going to bring Jordan on the stage now, but while I have you here, just want to, something I forgot to say in the beginning, bathrooms are also on the corner. And also one thing we want to thank Society Winwood. We also thank Andrea. Share. This kind of place, and Andrea can direct you to the right person, or I can help direct you to the right person. Staying in such a nice place. I can get the Wi-Fi for you.
Thanks. Let's say A2E2, 48A2, E2, C59,
323, 8A58.
yeah. I believe in it.
Sweet.
We're good.
Okay.
Yeah.
You have a HDMI?
Yeah.
Yeah, you do. Okay, sweet.
Let's see. This is.
I shared the screen yard with you.
So what do you need me to?
Yeah, so you go to Telegram to our DM. Perfect. Click that. And I'll bring you on the screen from there, but I'll need you to just put your name in.
Allow my cam access.
All that fun stuff. And also, I would recommend muting this tab.
Right.
And I won't show yourself here.
Yeah. What the hell? My has
Put Jordan there and mute that. So if you just like play sound crazy. Perfect.
enter.
Yes. Got it. Cool. Then go to present. Yeah. Present right here. Share
Entire screen. Yeah.
Yeah. Cool. Yeah. Share your whole screen.
What's this keynote thing?
Perfect. I would recommend full screen.
Yeah. Oh, sorry. I gotta. Entire screen, right?
You got it. You have the HDMI?
Yeah, it's on the other side.
Just enough room? Nice. Hold it still so I don't knock you over. There you go. Excellent. All right, cool.
Hey, you tell me.
Round two.
Woo. Okay, ready?
Okay, everybody, we're gonna start with Jordan's talk now.
All right, cool.
All right, let's do it.
I know. Yeah. All right. We're doing the talk now. All right. Yeah. All right, cool. Wait, hold on. All right, cool. Cool. So this talk is called Debugging Data Pipelines with AWS. All right, cool. All right, cool. So this talk is called Debugging Data Pipelines with AWS Athena, AWS Glue. I'm going to talk about a design pattern I've used in multiple different production systems that I find valuable and I keep coming back to. And then at the end, we're going to let some stuff rip live and see if we can have some fun. So very quickly, like, what is the problem that we're talking about that Athena and Glue I feel are so good for? So there's this concept I have of like things happening on screen in your application and things happening off screen in your application. So generally speaking, like we have a core application system that, you know, is our like web application or data models that we have like very, very tight kind of understanding of. We have things like unit tests and type checking to make sure that there's no like compilation errors. We validate schemas of objects and database validations. We QA like the common flows. Vlad did a great job talking about like how we just have like full understanding of our core application. But then there's always in systems things that happen like off screen. Like we have to reference third-party APIs. You know, users have stateful UIs that get into weird states when you're using our data. Like we have data pipelines that are going on in the background. And if we ever get like an error back into our system from one of these flows, it can get really, really gnarly to debug, like in like actual production applications. So a couple examples of stuff I've built that get this way, like during the pandemic, I built a poker site called Clubs Poker. it was a multiplayer poker client in your browser where multiple people could just play poker in their web browser. And there's this core application that was just super well tested, tightly tested. Like there's a state transition function of when a hand is in one state, somebody does an action, what is the next state that it should transition to? All the hand history is, super tightly tested, well understood, keeping track of people's chips, things like that. But then you get into all these issues of like, if a user has an issue in their browser where something doesn't render properly, well, is it an issue with latency? Like, did they just not receive some event from a server? Is there some sort of concurrency issue where multiple users are clicking buttons in a multiplayer game before they've received an event? Is there something with like their browser memory where like they have a lot of tabs open and like things aren't just rendering properly? So like all these off-screen things, super gnarly to debug. You do not have like the same observability and transparency into them as you do in like your core data models. My current project is an app called Blend-In. It's an AI native localization management platform where you can like translate strings in your application into multiple languages using LLMs. And this is kind of has a similar like system to it where you have a core application that's super well understood and tightly tested. You always know like what user project management, what the latest version of the translation files are, like if you need to upgrade them to different subscriptions for billing. But then you have this off-screen kind of stuff of like, okay, what are they typing into their CLI? Like, what are the things that they're expecting to happen? What happens when they kick off a translation job that might be translating, hundreds of strings concurrently at the same time? If something doesn't show up into your database correctly, it's like, you have this huge observability problem of like, okay, what actually went wrong off screen of like my application? So there's a whole industry around solving these kind of problems. Like Datadog, I think their starter tier is like $400,000 a month or something, where you just like give it all your data and it like figures this out for you. People build like custom Grafana dashboards and systems. And like my like approach to doing it is normally trying to first like solve this stuff yourself in like AWS before you have to reach to one of these complicated things. And this is a pattern I like keep coming back to because it's like using AWS S3, AWS Glue, and Amazon Athena. So everyone's heard of Amazon S3. That's like your, single. But like the B-sides over here, AWS Glue and Athena are also awesome. And I'm hopefully going to show you all how it works right now. So the core idea, and I guess like we could talk about like what all of these are in a second, but like the core idea of this is that at any piece of your system, you can create structured log objects. So logging is like its own whole industry. Metrics are their own industry. But I find it's like super helpful to just create structured log objects, which are just like JSON objects that you can put like compose anywhere in your system. And then you can write those log objects to S3. So S3, like I'll explain in a second, but like it is actually a great log store. And you can just dump all the arbitrary JSON data you want into it. And then what Athena does is Athena is a service for writing SQL queries among unstructured data. And AWS Glue is the way that you can have Amazon like crawl the data that you have in S3, create virtual schemas for it, and then you can use Athena to query it in SQL. And I hope this will make more sense in a second. So yeah, S3 is, if you've never used it before, it is the file storage system on AWS. It's amazing. It's like one of the most amazing products ever. It's a fully managed file storage system. Amazon's own marketing markets it as infinitely scalable, and like it's pretty close to accurate. It's always available, high durability, and it's really easy to configure like the lifecycle policies of it, where you just say like, okay, I want to like delete data that's older than 30 days or something like that. So this is a great file storage system. Now, Amazon Athena is a service that allows you to write SQL queries against any arbitrary objects in S3. And like normally if you're writing SQL queries, you have to like put it in a database, put it in this very strict like schema for it. You can't just like write it against log data in like bucket storage. But this is like the whole point of Athena. And Athena is awesome. It's like a service where the objects can be unstructured under the hood. You pay per query, so you don't need to pay for the amount of data, just the data that like you're querying. And as a general practice, this is a good pattern for running infrequent queries against large data sets, such as debugging like log data, because you're not doing it all the time. It's not like core to your application, but you want to do it like against large pieces of data, like when you can. And then Amazon Glue is like, it's called Glue because it's kind of the thing that glues these two things together. It's a service on Amazon that lets you infer schemas from unstructured JSON data. So essentially what that means is you can just take a bunch of JSON objects in a bucket and have Glue crawl it and basically compose a SQL table for it like live and just say, okay, given the data that's in this bucket, I think the schema of this is this, and that allows you to query against it with Athena. So Glue is like, you don't need to use Glue. You can just manually hard code what the schema of your data is against S3 and start querying it, but Glue is awesome because it just makes that a lot easier. So yeah, real quick, I guess we're gonna try to show what this looks like live. So this is actual code from the Blendin app. And we're gonna just like run some translations and try to set up a system where we can see what it looks like to log arbitrary data and query it with SQL. So the first thing you need to do is like, for those of you that haven't seen Terraform before, by the way, Terraform is just a domain-specific language for defining AWS resources. So everything here is just an AWS resource. You could go to the AWS console and do any of this. But essentially, let's see, I make a S3 bucket just called like logs bucket. And this is just any S3 bucket, and I'm just gonna write arbitrary JSON objects into this thing. And then I have a Lambda function that is called generate translation. And this is the function that, given an input string, can output a translation string. And all that I'm doing is passing in that logs bucket into the function. And you could see in the generate translation function, just this is a Lambda function that's running, you know, on AWS's data pipeline. I'm just writing a random JSON object into it with just some data that I want to see and be able to query against anytime this Lambda function runs. And you can do this at any part of your data pipeline. If you have like 5 different steps to the pipeline, you can just log arbitrary JSON data into the log bucket from any piece of it. If you have users, browsers, server, whatever, like CLIs, you can just log arbitrary JSON data, throw it all in that bucket, and just figure out how to query it later when you need to debug stuff. So again, yeah, it's just an AWS S3 bucket. And then I have the Glue resources that is basically just looks like this, where I'm creating a Glue catalog database, which I'll explain in a second, and a crawler, which I can use to automate taking the data that's in this S3 bucket and then just querying it. So yeah, the thing that I wanted to try testing live, and that's will be fun, is like basically Lambda functions on AWS have this parameter called reserved concurrent executions, which means how many of them can run concurrently at the same time. And I was just going to double this to 10, and then just like run a try to translate my app into a different language, and then we'll look at the data in Athena and see what it looks like. So if I go here and I run Terraform apply, I can just deploy that change on the concurrent executions. And then we can look like what we have on Amazon now. So this is the S3 bucket that I have, this Blendin logs. And you can see like there's just, you can partition the log data in any way that you want. This is also important. Like there's different partitioning strategies you can use. You can have this partitioned by day. In this case, they're partitioned by project ID. And you'll see this when we call this for the Glue schema. So then there's that Glue schema that I created. If I look at Athena, by the way, you'll see that it doesn't know about any tables associated with this log. Like so, or this bucket. So like I have an Amazon S3 bucket. Athena wants to query against it. We want to look at any object in this bucket that was created after a certain timestamp. So right now there's none, and it doesn't even know about this table. So I can use Glue to essentially, actually I should run the job and put some data in the bucket. So like the way that this Blendin works is I could just put a different language in here. So let's do, I don't know, what's a good language? Anyone recommend a language? Korean, okay, cool. So this site's not currently translated into Korean. We're going to translate it into Korean. So if I run Blendin translate, it'll come up with what's called like a translation plan. It'll say, these are all these strings I detected. We need to translate it into Korean. I'm just going to say yes. And that's going to rip that data pipeline where it's going to be executing that Lambda function in parallel. So it has 159 strings to translate. We up the concurrency to 10. So it should be able to translate 10 at a time. But again, like say one of these strings just comes back null to my database. It's very not clear just like why this translation job like partially succeeded or partially failed. But like we're going to have that observability because we're logging all that stuff to Athena. So this translates, our app should be in Korean now, which is sick. If you don't believe me, let's just real quick try to prove it. This is running locally. All right, so maybe it did not work correctly, but the whole point of it is to find out. So if we go to that log bucket, we should see a ton of objects that were logged. Let's see. Yeah, so like there's a ton of objects that were logged. This is each run of the translation job. That's that like custom data. If we go to AWS Glue, what I can tell it to do and why it's so good is I can basically say, just take that JSON data in that S3 bucket and create a SQL schema from it. So I'm going to run the crawler against the bucket. This normally with like that much data should take like a minute to run. So you could just like wait for a minute for it to run. And while we're doing that, basically this is going to be our query engine. This is just SQL that we can write against this table. And once that crawler is done, we should see what Glue infers to be the schema of the objects that we wrote here. So let's see. We have to wait for this to run. It's at 30 seconds so far. It'll probably take a minute. So we could stall for 30 seconds.
Question.
Yeah, go ahead.
Entirely unstructured like logs, and when you try and create a schema, I presume you can also export the schema. See what
Yeah.
things and-
Yeah, totally. And the cool thing is you can constantly change it. That's why I kind of like doing this over databases, is if I just forgot the timestamp field, I can literally just add timestamp to my Lambda function, and then it can just add it as an optional field here. And it doesn't matter if data before doesn't have it. It doesn't matter if data before matches. You can just say like, or you can just compose an ad hoc schema for a specific query and say like, I just want to query these fields in this data for this specific query. But like you can use your old schema for like the other like analytics that are running. It's pretty good at it. Like I've messed around with Glue a little bit. Like it can do CSVs, it can do JSON, it can take partition data like and just like kind of figure out like close to what the schema is. Okay, so this job completed. We'll go back to the query editor and we'll refresh it, and we'll see that it has detected a table. And again, I did not tell Athena or Glue that this was the structure that I wanted. That's nowhere in my definition. I literally just dumped JSON logs into an S3 bucket, and I said, go ahead and index it. And it came up with all of these fields, and it has this thing called a partition. And that's the way that I structured my S3 bucket, where if you look at the actual way that it's partitioned, is that there's this thing here, which is the project ID, and then everything's nested underneath it. So it can detect like, hey, there's a partition about something. There's something about it. So now I'm just going to run this and say like, show me every log job that ran. And you can see like I have this data. I can see like the source string value, and I could see the translation text that came in. So it's like I could say, okay, this actually did work. Like this is the strings translated into Korean. Like why it didn't render in the local host, like that's another question. But I can just like actually observe each run of that data pipeline, have full like indexing into it, and I am not paying Datadog $40,000 a month. I'm not, I'm not doing anything crazy with like database engineering. This is a fully managed solution. I can just dump all this S3 data, and when I figure out like what a query I want to run to debug something, you can literally just write arbitrary SQL. So like this is just SQL, and this is a table. Glue is not storing, it's not doing like ETL. What Glue is actually doing is it's just storing the schemas definitions. So you can have multiple different schema definitions, but the queries just run against the schema definition. They do the ETL in real time and then query your data and like just show it up here for like observability. So yeah, it's cool that we can see our log data for each translation job. We can see the timestamps, so we can get like some clarity on like how fast this thing is running. Like you can do like a bunch of like data analysis on this, like ad hoc in real time, and you don't need to worry about how you're like organizing, storing it. So yeah. This is Amazon Athena, but the data itself is stored in S3. These JSON objects are just being stored in S3. And these are essentially just logs. Like if I look, I don't think I'll be able to look at this just the way the permissions are, but this is just a JSON object that's in S3. And you can just write as many as you want. Like you can write 1 billion of them, it's fine.
You get Glue to organize it in the sense for you to make that call, right?
Go ahead, yeah.
You get Glue to organize it.
Yeah, Glue organizes it, and like it doesn't matter if some of them have different fields than others. Like it can just map that as like an optional SQL field. Like these can be different structures. Glue will do its best to like look at your whole data and just be like, this is what I think a table is. If a different object has a different table, it could be like, yo, I detected 2 different objects here. Like one looks like this, one looks like this, and they're different tables. So like query that table if you want that, query that table if you want that.
And then you get the
Yeah.
Oh, I don't know if this is trivial, but how does that inference process work for AWS? Down, no?
Oh, the crawling.
Algorithm that they're using?
Yeah, I don't know, man. I have no idea how the internals of Glue work. Yeah, Grant, you had it.
My question might be a little silly, but
Yeah.
But in terms of like being unstructured data and everything, but is there still best practice in terms of storing your log files into S3 buckets in this way? And sense of, for example, you just throw everything in
Yeah.
one log file, or I just let it.
No, there probably is. Like the way that I've done it before is by date. So it's like you basically organize everything under year, month, day, so that you can basically index an entire day, you can delete an entire day, etc. And just like you can query against a certain day, like like for whatever structure it is. So I've seen most things in production do that, but I don't know like what necessarily the trade-offs are for different structures. I think it just depends on what you need. Yeah.
Do you offer your rights to S3?
No.
Do you do the write in band or after the response is sent?
Ideally both. If you're debugging something, or like to me, it's just like every checkpoint of any operation, you can send a ping to S3. Like, so you could write, hey, this Lambda function is being executed at this timestamp. Hey, we got a response from OpenAPI's API with this data at this timestamp. And then like you could just look at the translation job and be like, for this translation job, what's every checkpoint that you said? Like generally speaking, as you get more and more into production, you just write more and more checkpoints constantly. Like there's no like real downside to doing it.
Wouldn't you have a pretty non-trivial impact on your performance? You're constantly halting processing. Just put an object into S3. Maybe if you're making a big sync, that's why I asked that.
Yeah. No, that's a good point. It could be that's the case. I haven't yeah. So his question was, are there performance implications for just checkpointing everything to S3, like in a Lambda function that's in like a core business process like that? And the answer is probably. There probably is a really smart way to manage doing that.
The performance question on S3 is very scalable, almost like Edge.
Yeah, no, it's
Yeah.
it's about the latency of waiting for input, right?
Like, if like several logs. Like,
Yeah.
I think there's this new thing in Vercel that lets you return and still keep the Lambda alive. If you're using one of those serverless functions, and it does like logs in the
That's
background.
what I meant.
Yeah.
Like the Datadog agent, like will literally like aggregate like tons of logs, and like when it's off, like the agent is just smart. But when it's
Yeah.
opportune,
Yeah, it's
for,
collecting standard hours in.
Yeah.
But like,
Yeah.
You can write more than one step.
Yeah.
I think.
Oh,
you
go
can
ahead.
Definitely scale this really
Yeah.
easily just by collecting them for a run.
Yeah, that's a good point.
And
Would
batch
would
them.
you think just putting it on SQS for like an S3 write queue, would that, or like the write to SQS is the same as the write to S3?
So I've done this before with SQS and then pushing from the SQS queue to CloudWatch logs. I thought that was way overkill. I guess if you want to have like a log forwarder job that takes the queue requests and puts them off, but I think in Lambdas, kind of like what Vercel has, you can, at least in depends on your language, but after your response is sent, you should be able to do some deferred cleanup, which is where you can just do it right then.
Yeah, that makes a lot of sense. Like maybe just at the end of the Lambda function, you batch write all the checkpoints. Yeah. Yeah, I think that makes a lot of sense actually. Okay, yeah, go ahead.
Yeah, you mentioned that you partition based on project ID. Could you, like, how do you decide what project, like, how do you set that up?
Yeah, I mean, this is just, so the kind of core thing here is that when you use the Glue crawler stores the different data, like the different values of the partitions that you have. So the Glue crawler, when you run it, it will know about the schema of your database and the partitions that exist currently. And if you add new data to an existing partition, the query will return that live data without any changes. But if you add new partitions, you have to have the Glue crawler run to index that partition in order to then query against it. So really, like I said, the way that I've seen most of this work is with time, like the dates, because then anything that's written in that date doesn't require Glue to reindex it. I was just doing it under the project ID for now, just to aggregate it and organize it, because this isn't like a super high volume system yet. It's still under development. But I think in production, generally doing it by day so that you don't ever have to reindex a partition is like a good strategy. Yeah.
And if you don't know this off the top of your head, totally fine, but, do you have a sense for pricing on this? Like, what's the cost?
Free emoji, like most AWS things, is just like you pay per byte scanned. That's literally how they do the pricing on Athena. So it's like the amount of, every time we scan a byte of the files in the query, you get charged. But like, again, like I've found this pattern useful, not for like constant data analysis, but for like, hey, something's really wrong and we can't figure out what, and we need to debug like every checkpoint. So you're running it kind of like on demand to fix something. So like you're never really like brushing up against like the limits that they have for it.
You're not running it like daily or weekly.
Yeah.
You're just running it on an ad hoc as a debugging tool.
Yeah, exactly.
That's good.
Infrequent queries against large data sets.
So if it's more like cash flows.
Yeah.
Yeah.
So it's okay for data now, but if it's not a warehouse, so for that they have like Redshift. But yeah, it's more like if you store a lot of data in S3, you can query that. It's like Snowflake.
Yeah.
Like the user work with that, so it's kind of similar.
So have you seen any performance issues?
Performance issues
Have you seen any performance issues?
on using
When you do this?
which piece of the,
Okay, so those are the lambdas that are writing, which I think the question over there. And then S3 actually takes 3,500 writes at the same time, 3,500 one write. So I don't.
yeah, I mean, like the Lambdas in this case are making API calls to OpenAI's API to get the translation. So I guess just in my mind, I was like, writing to S3 is not the like limiting region of that Lambda, like the,
And lambdas are not either.
yeah, exactly. So it's like, if you, like, this is only running 10 concurrent Lambdas. It translated my whole app into a language pretty quickly. In production, that probably gets kicked up a lot, like to like almost 1,000 concurrent. So like, I wouldn't be too worried about any individual Lambda having, you know, a couple hundred milliseconds or something. But I do agree that if in some systems that could be a big deal and like it'd have to be dealt with for sure.
Would you see this like pipeline effectively as like a good dashboarding like kind of solutions instead of, or would you see it like not?
Yeah,
that?
so-
Like that'll at cost, your dashboard gonna cost money opposed to hosting a database that's going right in there.
So the thing that I think, so are you saying like, what's the difference between this and just using a database?
Let's add that on, yeah. So the original question is like, you see using this pipeline as like a dashboard solution, so like create schema and then have some dashboard solution with a set of queries, like polling and reading over time, trying to get summaries of things.
Yeah, like generally, I guess, to me, like in my mind, I guess, like metrics and logging are like two separate things. So like dashboards are like metrics where they show you like what is, like if it surfaces like, hey, there's a lot of 500 errors coming out of these Lambda functions. It's like, oh wait, this is something that's like alerted on like a dashboard that something's wrong. But like actually figuring out what that something wrong is, like generally is like how you do logging solutions. And I think this is more of a replacement for logging solutions, where instead of trying to write like natural language logs or parse the CloudWatch logs or use like an expensive log indexing thing like Datadog, it's like I'm just writing structured checkpoints from things that are happening. And then I can go in and say like, why are these 500 errors happening? Where in the pipeline is something broken? And like actually just like on demand, like dive into it, you know? That, yeah. So I think of it more that way. I think it's really good when you can have multiple checkpoints, like if you have a more complicated data pipeline where like there's 3 different steps and SQS queues in between them, where each step of it is like writing to the same log bucket, and then you can just quickly aggregate it. Like show me everything that happened with this UUID. Like just give me the checkpoint of when it went into everything. like tell me when it went into this service, when it went into this Lambda, when it went into this, and like where is this actually broken? You know, like I had to do that with my poker site a lot when it's like, show me when the user's browser received the state here. Show me when this guy clicked the state here. Let me aggregate everything that happened in this hand and look at every timestamp of like a user's action in their browser, the server acknowledging it, the user like receiving this event, and like being able to like piece it back together was super helpful. Because it's like you have so many disparate sources writing into one thing and you can just lay it out in a line like that. Yeah. Yeah, that's a great way to think of it. Yeah, it's like just logging events that happen and just like being able to cross aggregate them later. It was called Clubs Poker. If it still exists, I own 6% equity in it. Yeah, go ahead.
I guess like if you're doing this locally, obviously you're not using this stuff to like write stuff locally, are you? And locally maybe you're just console.error or just like going to the console.
Yeah, to me this is a solution that like if you go back to that slide deck, it's like locally is the red box where it's like we have tools for this. Like I gave a great talk about it. It's like we have a lot of ways to just like get a handle on everything happening like locally in your app. This is more for like the green box of like when things go out and like you just don't know what's wrong with them. So it's like you need to like put like the child tracker on it and be like, yeah.
Cool.
All right, cool, thanks.
Two things. One, we have the space until 8, so feel free to network and talk. Second thing, we have a special birthday in the house. It's, Happy birthday to you. Happy birthday to you. Happy birthday, dear friend. Happy birthday to you. And yeah, thank you all for being here.
Awesome.
All right. Go to the communication.
Oh, thanks. I appreciate it.